Welcome. My name is Nathan Smith, and I am the Digital Programming Coordinator for the Central Arkansas Library System. Thank you so much for joining me. This is Hello World Intro to Code. I'm really excited to present this to you. This is a really fun class, and I hope that you get a lot out of it. We've got a lot of great live events coming up. If you head to cals.org, move your mouse over events, and click on search for an event in the menu that appears, then you should see those. If you want to look specifically at the technology classes that are coming up, head to cals.org, move your mouse over events, click technology classes, and click on the little button that says view and register for events. We've got a lot of cool stuff coming up next month, which I haven't quite gotten up on the website yet, but it's going to be great. So we've got a lot of kind of entry level stuff going on. So if you or someone you love wants some more basic kind of technology instruction, then it's a really good time for that. I'm also going to be going the other way, and toward the end of next month, I'm going to be offering a new class on using OBS, the Open Broadcaster software, which is a free open source program that you can use to run video live streams. So it's very, very relevant to our world right now, and so that's going to be fun. I'm looking forward to that one as well. So, Saturday also, something cool is coming up from 3 to 5 Saturday afternoon. We're going to be doing a panel discussion on the history of hip hop in Arkansas. I'll be on the back end running some technology things for that, but I did want to bring that up just because it sounds like it's going to be pretty cool, y'all. So show up and hopefully it'll be fantastic. Okay, a few other things. I always like to encourage folks to ask questions throughout my classes. Like, the point of a technology class is for you to learn things that are useful to you. And if something that I say is unclear to you, or there's sort of a lingering question in the back of your mind, you ultimately won't learn as much from the class. So anytime you have questions, please speak up and let me know. I do expect that there are going to be a fair few questions in this class, because it is it's kind of, to a certain extent, writing code is about training your brain to think in certain ways, and so it's it can be a little bit rougher to start. That's why we have this class. And so I definitely encourage you, ask questions whenever they come to you. Don't worry about if you're interrupting me. Definitely don't worry about if it's a dumb question. It's not. Don't worry about it. So just speak up whenever you have those questions. If you're joining me here in Zoom and you're on your computer, at the bottom of your Zoom window, you should see a little speech bubble that says chat. You click on that button, and that'll show you the little chat panel, or it'll pop up a little chat box if you're viewing this in full screen, and you can type your questions in there and I'll see them. Excuse me. If you're in Zoom on a mobile device, tap the screen, tap on more at the top of the screen, and tap on chat in that menu. That'll get you there. If you're joining me on another platform, Facebook Live or YouTube, you can use the comments or the chat respectively, and I should see those as well. There's like a slight delay, but honestly, it's not all that much. It's pretty minimal. Oh, somebody on YouTube. Hi. Great. So yeah, ask me those questions when they come up. That way we can make sure that everybody gets a lot out of the class, and that nobody gets left behind. The other big thing that I want to ask y'all to do, if you are, to get the most out of the class, is to please let me know as soon as you possibly can if there are technical difficulties. So if you stop seeing my camera and I haven't turned it off, or if I freeze up, or if my audio goes out, or if my screen share suddenly freezes and it's clear that I'm doing something, please let me know as soon as possible so that way I can fix the technical problems and we can make sure that, again, that we don't waste our time. I don't have to go back, 5 minutes worth of instruction in order to get you to where we were, or where I thought we were, I guess. So yeah, speak up if there are technical difficulties, use the chat or use the comments, and we will have a good time. Okay, great. So let me go ahead and fire up the screen share and get into my notes here really quick so that way we can get this, we can make it happen. There it is. Okay, so first things first, if you're following along, now some folks may just watch and go back and view the video later. That's and try to follow along at that time. That's perfectly fine too. If you want to follow along live, that's great as well. Whatever you're comfortable with, however you're going to learn best is great for me. If you are following along though, the easiest way to do what we're going to be doing is to, up at the top here, head to Trinket, or in your web browser, just open up a web browser and head to trinket.io/Python3. Up here at the top, if you see like an additional something up here, click the little gear and click delete. And then if there's still text over here underneath the tab that says main.py or py, excuse me, then go ahead, right click in here, click select all, and then press delete or backspace on your keyboard. So that way you get something like this. I'll give folks just a moment or so to do that. And then we will, get it taken care of. Let's see, so yeah, I'll give you just a moment here. Let's see. All right, excellent. There we go. Okay, so hopefully everybody is squared away. And you should have kind of a blank page here with two little windows. So what we're doing here, this particular web page is really handy. I use it for this class basically because it's a nice little web-based sandbox to play in when you're working on some code. They have other programming languages available. We're using Python today, and we'll talk about why in a second. But basically what we'll be able to do is put our code in here as we write it, and then over here we'll be able to see the results of the code, and that will be that'll be pretty handy. the nice thing about this, you don't have to install any software or do anything special at all. You can access this from any web browser, whether you're on Windows, Mac, a Chromebook, or whatever. So that's really useful. And obviously you can come back to this later on and play around with it some more. It's a great place to test some stuff out. Let's see. Oh, I got another question here. Give me just a moment. Let me sort this out. Right, excellent. Okay, so let's talk just briefly about what we're doing in terms of some of the basics. So when we talk about the programming language that we're talking about today is Python. Python is kind of a newer language as these things go, and but it has been around a good little while at this point. It's very beginner friendly, which is part of the reason it's not sort of as fussy about things like spaces and punctuation and stuff like that. And so that makes it a lot more friendly for folks who are just starting to learn how to use or how to write code. So that's that can be really so that's one of the reasons that I chose Python. Another reason is that whole thing that I mentioned earlier, where but the thing about this is, regardless of what programming language you learn on, they have a lot of things in common. So I'm going to show you this today, but I started out myself learning Python, and I was able to branch out to a number of different things, other languages that, I mean, I'm not a professional programmer. My job is teaching technology classes. And so I'm not, extremely fluent in any particular programming language, but of the three or so that I know a good amount of, I guess more like four, they have a lot of things in common. And it kind of works the same way because computers kind of work the same way. So if you're planning on doing something different that may not where Python may not be the programming language that's most suited to it, this will still help you a whole lot. I mentioned it in the description of the class, but I should also say The way this class works, where I'm not assuming any programming knowledge or experience from you whatsoever. We're starting from the very basics. So, if you're like, well, I don't know about this, I signed up, but like, I don't really know anything about it yet. That's why you're here. It's cool. That's exactly what this is. So let's talk about types of programming languages. There are your computer's sort of native language in a way is binary. If you've watched any TV show, you've probably seen like sort of a computer code that's like ones and zeros, a whole bunch of ones and zeros in a string. That's binary. It only has essentially those two characters, 1 and 0. Excuse me. And 1 and 0 also to a computer are the same as true and false, and on and off. Those basically mean the same thing to a computer at its heart. And so binary is essentially a series of ons and offs, or trues and falses, that tell the computer what it needs to do. But if you're writing code in binary, it can get really difficult very quickly. You don't want to try and write your code in binary for the most part, because it's not on the human side, it's not a very efficient way to do it. And it's just going to take a long time. So when we write code, we typically don't write it in binary because there are better ways to do it. If you're trying to take a cross-country trip, you usually don't ride your Razor scooter. That's kind of what it would be if you were writing your computer program in binary. But that's your computer's native language. And so there are a couple of different ways that programming languages get at this problem. One of those is to use what's called compiling. So in some programming languages, like the popular C family, you write the code in that particular language, and then you feed it into a program called a compiler, or that might be part of your program, what we call an IDE, or integrated development environment. That's just a fancy term for a program that's designed to help you write code. So a compiler might be part of your IDE. If it's a language that's generally compiled, you write your code, you feed it into the compiler, and then the compiler creates essentially a binary translation of your program that then any computer can run. And that can be really useful. Of course, writing or having a program that where you're distributing it in a binary form means that your computer is going to run the program very efficiently. Kind of like if I speak to you in your native language, you'll understand a lot more fully and a lot better than if I spoke than if I spoke in a different language and an interpreter had to translate, and we carried on our conversation like that. But there are languages that use an interpreter, basically, and Python is actually one of these. And the way that it works is when you write code in Python, your code stays in Python and you distribute the Python code directly. And then in order to run it, the user's computer has to have a program that translates Python into binary on the fly. So it's an interpreted language rather than a compiled language. For our purposes, though, that's fine, because we don't really want to have to wait for our program to compile over and over again. Instead, what we like to do is write our code, and basically, particularly since we're writing very simple programs during this class, we want to write our code and we want to see the results as close to immediately as possible. And so an interpreted language works a lot better for our purposes in this class. So that's the other reason that we're using Python. And that's a difference between two different types of programming languages that you want to be aware of. I guess one other thing to say, there are a couple of programs that you could use to that you could use to write your code instead of using this web interface that might be beneficial to you. One that you'll need anyway if you're going to run Python programs on your actual computer is the actual Python program itself. So if you go to python.org, you can click on downloads and you can download the version of Python that runs on your computer. And it should automatically detect what kind of computer you're accessing it from. Another that you might be interested in is that I like to use is Visual Studio Code. This is a little development program that is created by Microsoft, and you can add a variety of little extensions and stuff onto this program. It's got a nice interface, and it runs fast and smooth. So it's a really good option once you get a little more advanced. Visual Studio Code, definitely worth checking out. Okay, so that's all of that then. Let's go ahead and start writing our code, and we'll talk about the rest of it as we go. Okay, over here on the left, what I'm gonna do is, we're gonna write our first program. So the first thing you wanna do is type print, all lowercase, just like that. And then open a set of parentheses. So hold Shift while pressing 9 on your keyboard, Shift 9, and that'll give you a left parenthesis. And you'll notice that Trinket also fills in a right parenthesis automatically on the other side of my cursor. That's really handy because when you're writing code, whenever you have a left parenthesis, you have to have a right parenthesis. It's super duper important. Anytime you open something, you have to close it. So in the case of parentheses, if you have a left parenthesis, you got to have a right one. Inside of these parentheses, what we're going to do is first put an apostrophe. So on my keyboard, it shares a key with the quotation mark. And in computer world, when we're writing code, we actually refer to this, rather than an apostrophe, we actually refer to this as single quotes. So, again, it's basically treated like your standard quotation mark. And again, you do have to I'll put an exclamation point. Sometimes exclamation points do something in particular. In this case, it's just to add a little enthusiasm. So here we go. If you've written this out with me, following along so far, congratulations, you've just written your first computer program. Hey, hooray, all right. This is a little initiation tradition for programmers. The first program you write in a new language that you're learning is the Hello World program. And here's what it does. I'm going to come up here and click this little play button right here at the top. And you'll see it says Hello World right here. So let's walk through what we're doing a little bit. First of all, we're using this keyword print here. So print is highlighted in purple by Trinket because the word print with a set of parentheses after it does something specific in Python. To be more precise, what it does is it shows the text that you put inside the parentheses on the screen. So that's what we saw here, Hello World. Without the quotation marks, it's just the word print, and Python is going to give you an error message of some sort because it won't know what you mean. It knows that this is a keyword. It's actually what we call a function. So essentially, a piece of sort of pre-written code that tells Python what to do. When you say print and then you put something in the parentheses next to it, Python knows, okay, whatever's here in the parentheses, I need to put that on the screen for the user. You don't have to explain to Python or your computer how to do that. It's something that's built into the programming language automatically. A key piece of functionality. And so we'll be talking a lot about functions as we move forward. Depending on our timing, we might try to write our own one, but we may not have time to get to that. We'll see what happens. If not, it's definitely worth investigating. So inside of our parentheses, we have these single quotes, and then inside of that, hello world. The single quotes tell Python exactly what kind of information is inside of them. So in this case, it's what we call a string of text, or a lot of times we just say a string. A string basically just means some text that probably the user will see at some point. And so in this case, it's just the sentence or the phrase, hello world. If you put something that turns out not to be a string inside of these parentheses, basically it might or might not work. And so, and certainly if I put just hello world with no single quotes here, it wouldn't work because what we're, by using the print, inside of the print function, Python will only accept a string of text or multiple strings of text, generally speaking. So, putting it inside the single quotes tells Python, okay, this is some text, even if some of the characters inside here might mean something special or different outside of the string. This should just be treated as words, basically. So we've done it. We've written our first program. If all of that I just said didn't quite land with you, that's okay. We're going to have plenty of practice with it, and I think you'll continue to have more and more understanding of it as things go on. Let's go ahead and make something that's a little more interesting, though. We've only written one line of code in our first program, and honestly, it doesn't do very much. Like, if you run the program, it just says hello world, and then you're done. So we want to add some interactivity to our program. So let's write something a little bit different. I'm going to leave this print here. So print and then the open parentheses. Got to have the parentheses in order for Python to realize that it's it's the print function that I want. Inside of the print function this time, we're going to write, what's your name? Question mark. And we've got a problem, which you can tell by the color coding here. Excuse me. A lot of software that's designed to help you write code is going to color code things for you like this. Basically, that helps you figure out how your code is actually going to be read by the computer. So in this case, we can tell there's a problem. We wrote, what's your name? And it should all be read because it's supposed to all be part of the same text string, but it's not. The reason, of course, is we've got what inside of single quotes here. I put an apostrophe, but Python interprets that as single quotes. This is the end of your text string. And so anything outside of that is not considered to be part of the text string. So we have a problem. If we tried to run this, well, even if we finished off the line of code, it would give us an error. So what we want to do is give Python a way to know that it should treat this apostrophe as part of the text string rather than as a single quote that ends the text string. So I'm going to come over here and I'm going to click between the T and the apostrophe, like so. And then I'm going to put a backslash here. The backslash, of course, if you're, I can't quite visualize it on a Mac keyboard because I don't have it in front of me, but on a Windows keyboard at least, the backslash is the one that's over the enter button. I guess that's the return button on a Mac keyboard. But the backslash is just above that, not the one that shares a key with the question mark. So what's your name? Now that I put this backslash in front of the apostrophe, Python knows, oh, this is just part of the text. And it's going to put the apostrophe in the text, but it's not gonna end the text string with that. In this case, the backslash is serving as what we call an escape character. That basically says, treat this character like part of the text rather than treating it as a special character that means something inside the programming language. And most of the time, when you need an escape character, you use it exactly like this. You put the escape character, and then you put the character that you need right after it. Now, of course, as I said, when you open something, you've always got to close it. So I'm going to put another single quote here at the end after the question mark, and another right parenthesis since I deleted the other one. So now we have print, what's your name? And as you might imagine, if we ran this code right now, it would show what's your name over here on the side. But we're going to keep going. Let's add our interactivity in here. For this line, we're going X equals sign, and then input, and a set of parentheses with nothing in between. That's our line 2 right there. X equals sign, the word input, and then right next to it, a set of parentheses with nothing in between. So what this is going to do, let's actually talk about this line in reverse. So when we say input with just these parentheses here, as I mentioned before, anytime we use a function, anytime we're calling on specific built-in functionality from Python, we've got to have the keyword or the name of the function, and then we've got to have parentheses next to it. For the print function, we actually have to put something inside the parentheses. But for this input function, we don't. Because what's going to happen is the input function tells Python, give the user a chance to type something in. So, by putting this input here, we're telling Python, okay, give the user a line where they can type something and press enter to put it into the program. Once the user puts something in, then it's actually going to be stored in our program. That's why we have the X equals here. What's happening here is X is what we call a variable. And you can think of this in a couple of different ways. One way that you can think about it, and kind of the way I most commonly think about it, is as a container. So, when I have this line here, X equals input, if someone types in, Billy, then what will happen is the word Billy is essentially going to be stored inside this X. And whenever we put X in the rest of our code, essentially Python is going to replace that with Billy, the thing that's inside of the variable. So a variable can be thought of as a container or as sort of a placeholder, kind of like you do in math. If if you've taken an algebra class at some point, you have like, x squared equals 2x or whatever, and x represents a specific value. And so this is the same sort of thing. X is going to represent, in this case, whatever input the user gave us. In other cases, it could be something specific that we code into our program. It just depends, but it's sort of a placeholder. Another way that folks think about it sometimes is as a pointer that sort of says, okay, out of all the possible out of all the possible values that exist, I'm talking about this one right here. Again, if that doesn't super make sense to you right now, it's okay. Like I said, we'll get a lot more practice with it as we move forward, and you'll see a lot better how it works once we run our program. In order to do that, though, we need one more line of code here. So I am going to use my print function again. I'll type the word print, open a set of parentheses, and open a set of single quotes inside there. So print, left parenthesis, and then an apostrophe there. Inside of the single quotes or apostrophes, I'm going to put hi, comma, space. Make sure you have the space there. So it's inside of your single quotes, your apostrophes, you get hi, comma, space. The space will become important for reasons that, well, you'll see in just a second. But I guess I should say, like, one of the reasons that that sometimes, well, most of the time in writing code, things like punctuation and spacing are pretty darn important. And so whenever you're writing code, you'll usually see, the program that you're working in, we usually use what we call a monospace font like this, which means if it's a space or if it's a parenthesis or if it's a comma or if it's a letter or a number, it all takes up the same amount of horizontal space. So, so that I can always tell exactly how many characters are in each line. And if there are some weird stray ones, I can get rid of them because I probably don't need them. Okay, so what I'm gonna do now, I've moved my cursor outside of my single quotes. And then I'm gonna put a plus sign and I'm gonna put X right here, our good old variable X again. So what this does, the plus sign is, in this case says, okay, add the next thing after this plus sign onto the end of what I have there. This is one of your fancy $5 computer words to come away from this class with. Specifically, what we are doing is a concatenate operation. We are concatenating two pieces of text. All that means, I'll write that word for you right there. All that means is that we're taking a piece of text and putting another piece of text next to it. So there you go. If you want to impress your friends and confound your enemies, there's your vocabulary word for today, concatenate. Let's get rid of that. This is our program. Let's try it out. I'm going to come up here and hit the little play button at the top. And it says, what's your name? And then gives us a little blinking cursor right over here so we can type something in. So I'll say Nathan, and I'll press enter. And then it greets me by name. Hi, Nathan. So there we have that. So now, we've got a piece of code that's that is actually interactive, and that's worth that is that's pretty cool, honestly. And we're going to add a lot more interactivity as we move on. I got a question that I missed in the chat a second ago. I apologize for that. Excuse me, but someone asked, would a double quote do the same as the sort of backslash and then the apostrophe here? So let's talk about that really quick. You can't, I think that the answer to your question is yes, if I'm understanding it right. Instead of using the apostrophes as single quotes, you could actually do this. Put double quotes, or kind of what we think of in the US as normal quotation marks, around the text, and then have an apostrophe in here. Because we started the text string with the the double quotes, the kind of US standard quotation marks, putting a single quote character in the middle of it won't end the text string. So that's actually more convenient in this particular situation. But the reason I'm showing you with the single quotes is two things. Number one, not every programming language does that. So in some programming languages, you have to use the single quote, no ifs, and, or buts about it. And it can be advantageous in certain situations to use the single quotes rather than the double quotes. And I guess the other reason is just to show you the functionality of the escape character, because in certain situations, you'll need to use an escape character regardless of which type of quotation mark you're using. You'll need to use an escape character for other kinds of special characters that mean something in your programming language. So it's really important to know that escape characters exist, so that way you can use them when you need to. That is a great question. Thank you so much for asking that. Again, I'll just emphasize, as I said at the beginning of class, anytime you have questions, please speak up and let me know. Okay, so let's look at what the code did all together, and then we'll move on to our big example that we'll be working on for most of the rest of the class. So first, we have line 1, print, what's your name? That's pretty easy. Actually, let's run this and make sure I was right about that. Yeah, okay, good. So we have print, what's your name? Obviously, that just puts the text, what's your name, up here at the top to prompt the user like, hey, you need to type your name in now. Then we have x equals input, the input function. The input function gives us the little blinking cursor over here so we can type. So we type something in and we press enter. And then the x equals assigns that text that we typed in, that value, as we say, to the x variable. So now anytime we put x in the rest of our code, Python is going to fill that in with, in my case, Nathan. So down here on line 3, both these previous, this all comes together. So again, we have print, and then it prints just the text hi, comma, space. Then we have the plus sign, which is that concatenate operation, putting some text next to some other text. And then we have the x after that, which gives us, or which fills in whatever the user typed in as their name. So that way we get hi, Nathan. And because whatever the user typed in the input is considered to be a text string, just like this or this, we don't have to put any quotation marks down here or anything like that. The value that's, the value or the text that we typed in and the type. In other words, the fact that it's a text string and not, say, a number or something else. We'll talk about a few, another type or two here shortly. The fact that it's specifically a string of text is stored along with the information itself, the actual characters that they typed in. And so we don't have to put quotation marks of any sort around this X here. And in fact, if we did, what it would say is hi X, regardless of what we typed in on the previous line here. All right, cool. So any questions about those two examples before we move on to something a little different? All right, cool. Let's do this thing. Okay, so the next one that we're going to do, we are going to keep this print function up at the top. So I'll get rid of that. So print, and then I'll open my single quotes, are, and then in the middle of the single quotes, we're going to type, are you hungry, question mark, and then close our parentheses. I should mention, in some programming languages, Python is not like this, but in some programming languages, you actually need a character at the end of each line to signal that line of code is done, basically. So I learned for my game design class that I offer sometimes, I learned a good deal of C#, and in C#, every line of code, except for certain specific circumstances, has to end with a semicolon. So in that language, I would type, it would be phrased slightly differently, but I would type something like print, "Are you hungry?" semicolon, and then we do the next line, semicolon, and then we do the next line, semicolon, and so on. And if you leave those out, it's not going to work, because your computer, I don't know if y'all know this, but computers are super duper literal. So if you tell it to do something, it will exactly do that thing, basically. Now, that gets a little complicated, and sometimes computers do things that we definitely don't want when we could swear we're telling it to do the thing that we actually want it to do. And the reason for that is, well, it usually comes down to either an error on our part or an error on the part of the people who wrote the computer program that we're using, or maybe a combination of those. But, assuming that all of the physical parts of the computer are working correctly and were designed correctly, a computer will do exactly and only what you and the people who wrote the software it's running ask it to do. So that's why it's pretty important as you're writing code to be very precise. You want to make sure you're paying attention to spacing, paying attention to punctuation, paying attention to capitalization. All of that stuff matters in writing code. And so attention to detail is really paramount. But on the other hand, what that means is, if you can just sit down and look at what's there and really see it and see the details of it, then it makes it, in a way, relatively straightforward to write code. So just pay attention to the details is really all I'm saying here. Okay, after that tangent, let's get back to this. So we've got print, "Are you hungry?" which obviously we'll put "Are you hungry?" at the top up here. Next, on line 2, we're going to say, we're going to add a little, where is it? Oh yeah, okay, good. We're going to add yn equals the input function right here. So we've got yn equals sign and then input with the two, with the set of parentheses with nothing in between right there. So what that's going to do is tell us, so obviously that's going to give, just like happened over here in the last program, that's going to give the user a chance to enter their answer to the question, "Are you hungry?" in this case. So here we go. Let's head down to the next line. Here on line 3, we're going to throw a new wrinkle in here. All right, so first we need the keyword if, all lowercase. So if yn, our variable that we had up here, then 2 equal signs, make sure that it's 2 of them. And then in single quotes, the word yes. And finally, after those single quotes, a colon right here. So shift and then the semicolon key. It's right next to L if you're not sure. It should be the colon, 2 dots, not the semicolon, which is this little guy right here. Cool. So what we're introducing now is a little bit of what we call in coding flow control. And if you think about that metaphor pretty literally, you'll be well on your way to understanding what flow control is. So if you think about, you know, say a river, if you have a river and you use, you know, use kind of locks and dams to sort of control the way that that river is flowing, then the water will end up in different places depending on how, you know, depending on how you, depending on what you do with that equipment. So, you know, if you have, so you could direct it in different ways. You could make the water stay up here longer and, you know, and be kind of a deeper area, or you could sort of, you know, or you could let it flow through sort of at top speed, you know, in a particular part. You can use it to sort of alter the course so that it flows around, say, you know, a big patch of agricultural land or whatever. So flow control in a computer program is the same way. Rather than just going straight through the program line by line by line by line, which is what we've had so far, flow control allows your program to skip over certain parts of the code that you don't need to use, or to go back to certain pieces of code that that are further up in the you know, in the script, or to end the program altogether at different points. And so that is what this if keyword, our if statement that we're writing is going to do for us. So I've got this: if yn double equals yes, colon, and I'll hit enter. When I hit enter, you'll notice that since I've got the colon here, my next line is indented. Rather than using punctuation very specifically, Python cares a lot more about indentation. So it gives me a little indentation here, and that tells Python something important. It tells it that essentially whatever I write on this line goes along with, is sort of is kind of subsidiary to this line up here. It's something that's sort of dependent on it. So well, let's put something there. What I'm going to do is say print, open a set of parentheses, open my single quotes, and I'll say dinner time will be here before you know it. Okay, excuse me. So this is actually a complete program as it stands. It's not all that we're going to do with it, but it is complete. It will work and do something. Let's see what it does. I'm going to click the little play button up here at the top. Print, are you hungry? So it shows, are you hungry? It's text here. Yn equals input. So it's going to give me a little flashing, blinking cursor here that I can use to enter some information. And then if I type yes, then that gets stored with this variable yn. And then we're going to come down here and check to see whether yn is equal to yes. That's what the double equal sign means. We've already used a single equal sign. The single equal sign tells Python assign this value to a variable. So in this case, when we type yes, we're assigning that value, the text string yes, to this variable yn, so that it's stored with that variable. But then if we are, and so now what we're doing is taking whatever's stored with that variable and comparing it to this text string that we just wrote out, yes, right here. That's what the double equal sign does. Rather than assigning a value, it compares two values to see if they're equal. If it turns out, yeah, they are equal, then we're going to come down here and follow the instructions that are indented underneath the if statement. So The line that we have indented here is print dinner time will be here before you know it. So if I press enter on my keyboard, weird. Okay, we've got a problem. Let's try this again. There we go. Don't know what happened there, but it kind of decided to be weird on me. So it says, are you hungry? I typed yes, and then it says dinner time will be here before you know it. But right now, we don't have any other options. So if I run this again and I say no, then nothing happens. My program's over. So let's give another option here. What we're going to do is we're going to use another keyword here called elif. So I'll press enter. When I press enter here at the end of line 4, it brings me down to line 5 and it indents line 5 because it figures that I might have more instructions to give if the answer turns out to be yes. But I don't. In this case, I only need this one line that says print dinner time will be here before you know it. So I'm going to hit backspace to get rid of the indentation so that what I write next is going to be on the same level of indentation, essentially along the left side here, as the if function. And what I'm going to put here is elif. And a little preview, elif is just else and if put together. We're going to use else by itself in a minute, but this one is elif, which will give us the option to add additional options essentially after this. So we'll check to see if what the user typed in matches with yes. If it does, great. We'll print dinner time will be here before you know it, and that's pretty much it. If it doesn't, then there's another option. Okay, it doesn't match yes, we know that. But what if matches no? So I'll put double equal sign, and then inside of single quotes, no, and then outside of the single quotes, a colon. So I have elif, E-L-I-F, double equal sign, no in single quotes, colon, and then I'll press enter to head on down to line 6, which is again indented. So everything that's indented below the elif statement is going to run if the user answers no. We'll go print again, open our parentheses, open our single quotes, and we'll say good, semicolon, it. So I'm actually going to say it's. So I'll go ahead and put my backslash apostrophe s so that I've got using my escape character there. It's probably easier to write code when you, whoops, forgot it that time, backslash apostrophe RE. So you're not hungry, period. And I'll make sure I add my other single quote here. So I should have, if you write it with the contractions like I did, it's and your, you should have 2 backslashes in there to escape your 2 apostrophes in the middle of that text. So in this case, what's going to happen is we're going to do, if their answer is yes, we're going to put dinner time will be here before you know it. If their answer is no, we're going to respond, good, it's probably easier to write code when you're not hungry. Let's check and make sure that still works. Whoopsie, okay. We've got an error message here. And actually that's good because I wanted to make sure and show you these error messages because there's something important here. Okay, so we have the name of our file, which in this case, it's the name of the sort of file that lives on this web server. So that's not particularly illuminating for us. If we had multiple files though, this would tell us exactly where the error is in our code, like which file the error is occurring in. And that can be really useful. Then we have this, line 5. That's super duper important. And that's why whenever you're writing with software that helps you write code, you'll always see these line numbers over here on the left. If you didn't have those, even though it maybe looks a little weird, it would be really hard to find where your errors are. And you probably have to do a lot of like searching around inside of your file in order to find the problem. So when it says line 5, we know, oh, it's right here. This is where the error cropped up. And then it actually goes so far as to print it out for us and give us a little caret pointing to exactly where the problem seems to lie. So elif double equal sign and then no, I forgot something important, which is the name of the variable. We're not comparing elif to no, we're comparing the value of the variable yn to no. So I've got to type that in there, yn, put a space there. By the way, a lot of the spaces that I'm adding, now I do need a space between elif and yn here because they're two separate things. But between yn and the double equal sign or between the double equal sign and the text string here, I actually don't need spaces, but I am adding them because it's just a lot easier to read. So now I know, okay, this is where I have the problem. And I can go in and fix it. And it's easy. Let's try it again. All right, now, yay, no error message. All right, are you hungry? I'm going to say the yes, we haven't changed that code, so we know that that works. I'm going to say no. Good, it's probably easier to write code when you're not hungry. But what if I do something like meh? Then my program just ends. Nothing happens at all, which is not the worst thing, but we could make it a little friendlier to our user by adding some additional functionality here. So after my print statement here, I'm going to press enter. Again, this is indented, but we don't need it to be, so I'm going to backspace. And then I'm going to use the keyword else. So my else statement, basically what's happening here is we compare yn to yes. If it's yes, great, we know what to do. Down here, we put dinner time will be here before you know it. If not, we go down to the elif statement and we compare it to no. If it's no, great, we're all set. We'll say good, it's probably easier to write code when you're not hungry. If it's anything other than those two, then we go to the else scenario. And at that point, whatever code we put on the next line indented, or the next lines indented, are going to be what we do. So on this line, we say print, open our parentheses, open a set of single quotes, and I'm going to say you didn't, again, \apostrophe T, really answer my question. Cool. So now if I run this again and say, nah, you didn't really answer my question. So that will tell the user, like, I mean, you know, there's a possibility if you had that interaction with a person, you might understand what they meant by meh, although it's probably going to come down to tone of voice to a large extent. But the computer, which can only read text or can only process text, I guess, not even really read, doesn't understand. So you can only give it a yes or no. Let me show you one additional little thing that could be that could sort of cause a problem for us when we're when our user is working with this. One of the things that you always want to do when you're writing code is to try out a bunch of different things. Essentially, really, what you want to do is try and use your programs like the worst user. So in this case, I said meh, because I knew that the program was looking for a yes or no answer. So I kind of tried to break it that way. And it sort of worked before I added this else statement to it. But I could also, but there's another little glitch here that we want to be aware of. Are you hungry? Yes. You didn't really answer my question. It let me put this little backslash here before it ended the program. That's odd. Yeah, so we have a problem. And the reason that this is happening is even though we typed yes, Y-E-S, and nothing else, it doesn't match this exactly. Because remember, I said punctuation and spacing and case, like capitalization, all matter in writing code. So my computer is taking me very literally here. It's saying, well, lowercase y, lowercase e, lowercase s is not the same as capital Y, capital E, capital S. And so it says, and so it doesn't match this. And therefore we end up getting, you didn't really answer my question. So I'm going to show you something. There are other things that we could do to kind of like, to make this work, a variety of different things. But there's a really easy way to go about this. And I just want to show it to you, number one, so that you see like the difference that the capitalization versus not makes. But also, and you know, and that's a demonstration of why capitalization is important in code, but also just so you're aware of kind of some of the things that you might want to dig into later on. So what I'm going to do is at the end of this where it says if yn, I'm going to actually add something here. If yn, I'm going to add dot lower right here. And then I'm going to add a set of parentheses with nothing in between right after that. So that leaves us with yn dot lower and then a set of parentheses. What this is this is actually called a method, and that gets into some other stuff which has to do with what we call object-oriented programming. You don't have to worry about what that means right now, but basically what this is this lower is a function that's built into every variable in Python. So you can use it to act on the variable that you're working with just by adding a dot and then the name of the function after it. So really what we're doing is, so what this is doing is taking this yn and essentially whatever the user put in up here on the input line, we're turning it all lowercase before we compare it to this. And so that way, however the user capitalizes the word yes, it will all be turned into lowercase, and then it will be compared to this all lowercase yes. And so it'll turn out, Python will accept yes with any capitalization. And I'll do the same thing down here with the no, just so that so that it'll all be consistent. I'll hit the little play button. Yes, dinner time will be here before you know it. No, good, it's probably easier. No, that all works. So that's a nice way to sort of fix that problem. And these are the kinds of problems that you want to test for, because your users they just expect the program to work. And so if you have in mind exactly the way you want them to do it and they don't do it exactly that way, then your program's going to break more often than not. And so you want to try things out in a variety of different ways to see, or to essentially try to break your own program so that you can then fix those problems before they arise for the user. Cool. So let's add some additional functionality to this program. It's kind of a plain old regular program. It's got some useful things about it. Well, one thing I want to do for my user to make it easier on them is we know that they have to answer yes or no. It can be, the capitalization can be whatever they you know, whatever they want it to be basically, but they do have to answer yes or no in order to use our, in order to get a meaningful response from our program. So what we want to do is give them more chances to give our program a response that it understands. So let's make that happen. What we're going to do is we're going to use what's called a loop in order to accomplish that. So first things first, I'm going to bring this down a little bit. I'm going to come up next to this print function, and I'm actually going to press enter a couple of times to make some space at the top. Then I'm going to write the word counter, put an equal sign, 1. Counter equals 1. So what I'm doing here is I'm creating a variable called counter, and I'm assigning it the value 1. So anytime I put counter in here, it's going to represent 1 at first. We'll see how that changes as we move forward. But for now, anytime I put counter in here, it's going to Python is going to fill in 1 in its place. So counter equals 1. And I'm going to leave this blank area here just to make it easier to read. Never hesitate to put in blank lines in your code to make it easier to tell what parts belong with what other parts. That can sometimes be a lifesaver in terms of reading your code after the fact. So, I definitely recommend that to you. Okay, so we've got this line here, counter equals 1. So that sets up a function called counter and sets the variable to 1. Okay, so let's see. The next thing that I want to do is I want to, got so many windows open here. I'm going to close a couple of these. There we go. Okay, so the next thing I want to do is, start my loop. So I'm actually going to add one more line here. And then I'm going to say on line 3, while, and you'll notice that turns purple. So that's a keyword like print, like if, et cetera, et cetera. So while counter, so my variable is less than 4. So the less than sign is the one that's kind of looks like an arrow pointing to the left. On my keyboard, you hold shift while pressing the comma key. The greater than sign, of course, is the opposite. And the way to remember that I learned from 4th grade or something is the alligator always wants to eat the bigger number. So, so in this case, we're saying counter is less than 4. So 4 is the bigger thing, counter is the lesser thing. And in this case, when we start out, it is because, of course, 1 is less than 4. So there we have it. Okay, then I need a colon after number 4 here. And then I've got to adjust something. Unfortunately, this is a little tedious, but it's okay. It's not gonna kill any of us. What I'm gonna do is come down here to line 4 next to the word print, and I'm gonna hit tab to indent that line. And then I'm gonna come down to the beginning of line 5, hit tab again. Line 6, hit tab again. Line 7, hit tab again. Line 8, hit tab again. Line 9, hit tab again. Line 10, hit tab again. Line 11, hit tab again. So what I should have here is the first print statement where it says, "Are you hungry?" should be indented once, as should yn equals input. And if yn lower equal double equal sign yes, colon, all of that should be indented once. If I get, and then down here under, and then these 3 lines, these 3 print statements that I've been using, those should all be double indented. And you'll actually see a faint little gray line right here where it shows that it's indented and then indented again. So what that tells what this setup tells Python is everything from line 4 on down is inside of our while loop that we're setting up. Everything from, or, you know, and then in my case, if you've added more blank lines, it could be different. But in my case, line 7, line 9, and line 11 are all indented twice, because not only are they inside the while loop, they're inside of the if, the elif, and the else statement, respectively. So let's do a couple of additional things to make this looping process work correctly, and then we'll talk about how it works. So down here after line 7, where it says dinner time will be here before you know it, I'm going to hit enter at the end of that line and insert a second blank line that's still indented here. And I'm going to just type the keyword break. Pretty easy. I'm going to do the same thing on after line 10. So I'll go to the end of line 10 and type, press enter and type break on line 11, double indented. Finally, after line 13 here, where we have our else statement, and then you didn't really answer my question, I'm going to add 2 more lines of code. The first line is going to be counter equals counter plus 1, like so. Counter equals sign, only 1 equal sign this time, and then counter again plus 1. And then 1 more line after that, which is continue. So I'll give folks just a moment to finish typing that out. Okay, so let's break this down and talk about how it works. Anytime that you write code, the computer starts at the top and works its way down through the lines that you wrote, unless you use some type of flow control to redirect it somewhere else. In this case, we've got counter equals 1 first. So we create a variable named counter, and the value that we assign to it is just the number 1. This is not a text string like, are you hungry, or yes, or whatever the user is typing in here. This is the number 1. So it's a different type than a string of text. And so just bear that in mind. This could be compared directly with another number, whereas, like 4. Whereas a text string, if I had 1 in single quotes like this, that would not work, because Python is going to think of this as the character 1 or the numeral 1 rather than as a mathematical value, basically. So it's thinking of it as text rather than as a value that you can do math operations on. So I've got counter equals 1, setting that variable counter to 1. Then we get into our while loop. So we have the word while, W-H-I-L-E, counter is less than 4, and then a colon. So the colon tells me, hey, what you're going to see on the next line is dependent on what you figure out here. So basically, each time that Python tries to go through this loop, it's going to first check the value of the counter variable here. If it's less than 4, not less than or equal to, but just less than 4, then it's going to run the code that's inside of the while loop till it gets to the end, or runs into something else, which we'll talk about in a second. And so assuming that nothing breaks it out of that loop, it will keep running until the value of counter gets to be equal to or greater than 4, at which point it will skip over. And we might actually even put, just for the sake of clarity, down here at the bottom, I'll put 1 more print statement that's not indented at all. End of program, just like that. So now, whenever it comes to the end of the program, we'll know, because it's going to be harder to tell sort of visually over here when we run this. Okay, So we print, are you hungry? Let's actually watch what the program does and you'll get an idea and then we'll talk about it. Are you hungry? So if we say yes, it's actually going to do the same thing. Dinner time will be here before you know it. And we'll also add a end of program here. No, good. It's probably easier to write code when you're not hungry. End of program. Good. Okay, let's see. Are you hungry? Meh. You didn't really answer my question. Are you hungry? Ooh, you didn't really answer my question. Are you hungry? Wah. You didn't really answer my question. End of program. So what's happening? Every time that our program enters the while loop, it checks to see whether the variable counter has a value less than 4. If it does, then we first get this line that prints, are you hungry? Then we get the line where it asks the user for input. So we're going to, we're going to give them a little blinking cursor and the chance to type something in. Once they've typed something in, we compare it to yes. And then if it's yes, then dinner time will be here before you know it. And then we hit this break line. What that does is say, okay, we're inside of a loop, but we've actually done the thing that the loop is designed to do. So we need to get out of it now. And so when we hit this break, Python goes, okay, done with the loop. And it skips on down to the next thing below the loop. That's not essentially the next thing that's not indented, whatever that is. If it doesn't match with yes, then we look at no. If it's no, then we print good. It's probably easier to write code when you're not hungry. And then we hit another break here. So we break out of the loop and we don't go back to it and we get the end of the program. If it's not yes or no, then we trigger the else. We print, you didn't really answer my question. And then we get counter equals counter plus 1. What that's going to do is, it's again, we've got counter equals. So we're assigning a specific value to the variable counter. But the value that we are assigning is actually the current value of counter plus 1. So in this case, we're taking the current value of counter, we're adding 1 to it, and we're assigning that new value to the counter variable. So counter goes up to 2. And then we hit this line that says continue. The continue line tells Python, okay, you know, we're in the loop and we need to stay in the loop if we can. So once it hits continue, it goes back up here to the top of the while loop and checks again to see if the counter value is less than 4. If it is, then we continue through that loop. If at any point in the loop, if at any point when the user is prompted, they say yes or no, then we'll hit the break statement and the loop and the program will end. But otherwise, we'll keep going. And then after the third attempt, the program, or we'll hit the continue, we'll come back up to the top of the loop, and the program Python will look at the counter and say, the value of counter is 4. That's not less than 4 anymore. And so it'll skip over it'll break out of the loop entirely, and it'll come down here to whatever's outside of the loop after it in your code. So that's what a loop can do. It can basically give you a way to let a user try again on something, or a way to do a task repetitively until your program can tell that the task is done. And usually you want to have some method like a counter or some sort of check like this up at the top to see whether the loop needs to continue. If you don't have something like that, then probably what's going to happen is, if you don't have something that will break it out of the loop at some point, then your program will have an infinite loop and it won't work. It'll just, if your computer even allows it to run, then your computer would sit there chugging on it forever until you turn the computer off. And that's no good. Okay, let's do one last little improvement to this program, and then we'll wrap it up except for whatever questions y'all have at the end here. Okay, so let's introduce an element of randomness into our program. What I'm going to do is I'm going to come over here And again, I'm going to hit enter a couple of times to give me a little more space. And I'm going to type import random, just like that. So I'm going to type this in, import random. What that's going to do is it's going to give me a, it's going to give me what's called, oh, what do they call it? They call it something slightly different in Python. Hang on just a sec. Let me see if I can remember that. Okay, I cannot remember what the terminology was. I'll try and look that up in a second. But in most programming languages, this random is what we call a library. Basically, what it is it's an additional group of built-in functionality or, well, actually functions that allow you to that allow you to add additional, essentially add additional options to your code without having to write additional functionality into it directly. When you do this, what's going to happen is there are a bunch of functions that are sort of pre-built that become part of your code. So it can slow your program down if you use this and you don't need it. Excuse me. But if you do need it, there are a bunch of options related to randomness that you can just bring into your program with very little effort on your part, and that's very handy. Okay, Python calls it a module. A lot of programming languages call this kind of thing a library, but Python calls it a module. Regardless, we're bringing in that random module and so we're going to be able to use randomness-based functionality in our program. Okay, so here's what we're going to do. Next, I'm going to come down here after counter equals 1. I'm going to hit enter to add another line. And I'm going to type foods equals sign. So we're creating a variable called foods, and we're going to assign it a value again. This time, inside of the foods, inside of the foods variable, instead of just a string of text or a number like we've had before, we're going to give it a set of things, or specifically what we call a list in Python. In other programming languages, things like this could be called arrays. There's a variety of terms. In Python, though, we call this type of thing a list. What it is, so I'm going to open a set of square brackets. So the square brackets are right next to the backslash key on my keyboard. Actually, the left square bracket is right next to P. So I'm going to open up a set of square brackets. And of course, I get a right one because I have to have a left one and a right one always. I'm going to open up a set of single quotes, and I'm going to write a sandwich. Then I'm going to go outside the single quotes, put a comma, and then I'm going to write inside a new set of single quotes, some vegetables. Go outside the single quotes one more time, put another comma there, and then inside of a third set, a few chips. Okay, great. So now we have our foods variable. And what it has is a list of 3 text, a list of 3 text strings. The first text string says a sandwich. Second text string says some vegetables. And the third text string says a few chips. And so now what we want to do is have Python pick out one of these options randomly in a certain circumstance. So down here under the yes, so if yn.lower is equal to yes. Right now we're saying print dinner time will be here before you know it. I'm going to replace that inside of the single quotes in the print function here. I'm going to say here, comma, have space. Make sure you have that space there. If you don't have it here, then you're not going to have a space between the word have and the thing that comes next. And then we'll do plus random. So we're bringing in that random, we're referring to that random module dot choice. So inside of the random module, there's what we call a method, which is a kind of function called choice. We'll open a set of parentheses, of course, and inside of those parentheses, we'll put foods. That's our foods variable up there. Finally, outside of the sort of inner set of parentheses, but inside the outer set of parentheses here, we're going to go plus, whoops, not equal sign, plus one more time. And then inside of single quotes, just an exclamation point so that we make sure that we punctuate the end of our sentence. So what this is going to do, well, let me show you. I'll hit the little play button up here. We already know that our no and our else work, so we're not worried about that. What I'm going to do is instead say yes to are you hungry? And it'll say, here, have some vegetables, end of program. Run it again. Are you hungry? Yes. Here, have a sandwich, end of program. Run it again. Yes. Here, have some vegetables. And it is choosing at random, so it's not going to give us all three results right in a row like that. It's just going to pick one randomly. So what we've got is we have our import. So we've got our import random at the top. We're bringing in that extra randomness based functionality. Then, whoops. I accidentally made my chat window super huge. We use import random. That brings in our randomness functionality. We create a new variable here called foods, and we store a list of, in this case, 3 different text strings: a sandwich, some vegetables, and a few chips. Then down here under print, we will have it, if they say yes, we'll have it display on the screen, here, have space, and then we're concatenating, we're adding some text to the end of some other text, some text on here. In this case, a random choice from the list of foods up here, either a sandwich, some vegetables, or a few chips. So it'll look inside of this list and make a random choice between the options that we've given it and fill that in. And then we concatenate an exclamation point at the end there after that. So we have here, have space, the name of the food that we're giving them, and then we end our sentence with some punctuation. So that's pretty much it for today. There's plenty more to talk about in this, and I'll probably at some point in the future I'll be presenting some more material that's related to this that kind of builds on this. I have some more prepared, but I think it needs some tweaking. So I'm gonna work on that and hopefully have that ready. Maybe in April. I'll have that. I'll have that ready. So before we wrap it up, what questions do y'all have for me? Cool. All right, I don't see any questions right now. Oh, okay, I got the question. Can I save my code by creating an account? I think so. To be honest, I don't know that I've created an account on here. Yeah, you should be able to click sign up. Honestly, if you want to save your code right now, this moment, the easiest way to do it is I would just select it all, copy it, and then paste it into Notepad, or if you're on a Mac, whatever the equivalent is, TextEdit, I think. Um, and you'll be able to, you'd be able to copy and paste it later on, or you can even, if you install the Python program or Visual Code or Visual Studio Code or something else, you'd even be able to just rename that file, whatever you called it, .py, and it'll be the program, and any program will consider that to be a Python script or program. But surely, yeah, I would think surely if you created an account, you'd be able to save that. Okay, cool. So another question I got is counter a programming word? I lost you there. No worries, that's totally fine. So counter is just the name I gave to a variable. So like we had X or the Y in here, things like that. I could even call it, X equals 1. And then all I would need to do is just everywhere I see the word counter, replace that with X. And there it is. And it would do precisely the same thing. So that's just the name I gave to the variable. It's always good to name your variables something that's, you don't want it to be super duper long, but you do want it to be evocative of what kind of value is actually contained in the variable. That's why X is actually not a great variable name in most situations. You want it to be indicative of like what type of value is going to be stored there. So that's why I named it counter, because literally it's the counter to make sure that we don't go through the loop more than 3 times, because eventually the user will run out of patience, or they'll need to do something else or whatever. And we don't want them to be stuck in an infinite type of loop. Okay, cool. Okay. Thank you for that encouraging comment. I really appreciate that. Someone, in addition to some encouraging words, mentioned going back and watching the video. This is going to be available on the CALS YouTube channel and the CALS Facebook page. So you should be able to go back just anytime you want and check that out. So, yeah, feel free to rewatch and follow along if you want to really get it down. Another question I had, will future sessions also be in Python? Yes. That way we can build on what we talked about here. I might end up at some point building out and offering some coding classes in other programming languages. I don't have any plans for that just now, mostly because Python is such a good starter language. And once you've got a decent amount of experience under your belt in almost any language, you can branch out to almost any other. You just have to learn what the little differences are between what you already know and what you're trying to learn. Great questions, everybody. Anything else? If you do think of additional questions afterwards, or if you find that you're typing something just way too long, feel free to shoot me an email, digital@cals.org, and I'll be happy to tackle that. And in the meantime, I hope you all have a fantastic rest of your day. Thanks so much for joining me today.